Hello and welcome back to these videos writing a mini version of Rust in Rust, writing a little Rust interpreter using Rust programming language. Why? Just for fun, or maybe this will turn out to be useful for something. This is video 13. We are going to fix a bit of a limitation or a problem in our lexer today. So let's write a test that just demonstrates the problem. It should all be fairly clear. Let's call lex addition expression without spaces. So perhaps surprisingly, if you haven't been paying attention, this test is going to fail. So what this test says is when I lex, let's change the numbers as well, just to, because we'd like to keep things varied to make sure any edge cases might fall out. So this should, if it parses correctly, come out. Oh, and this is wrong as well. These spans need to be a little bit. No, like that maybe. We'll see. That might be wrong. Looks right though. All right. So yeah. We need to, this should parse into the number 77 and then a plus and then the number 399. But if we run these tests, I confidently predict that they won't work. And yeah, what happens is we get out the number 77 and the number 399, and the plus has mysteriously disappeared. And the reason is when we come against, when we're lexing, and we come up against a symbol that is not part of the number, we know that the number has finished, but we don't correctly deal with the symbol. We kind of hope and assume that there's some white space there that tells us the token has ended, and we need to do better. So let's have a look at how our lexing works. Now, this might be just a regular video for you, but I recorded quite a few up front, and then I had a break, and now I'm back, and so I've forgotten everything. So apologies if it's a bit slow. But yeah, when we're lexing, our kind of entry point is find the next token for me, please. And that says give me the next character, and then it says if it starts with a digit, then this must be an integer. For now, at least. So this is where our problem is, right? That we, when we find this integer, we don't, we swallow up the plus as part of, finding the integer. So let's have a look at, how this function works. So what this function does, it just goes through all the characters we've been given. We've been given the first digit, by the way. But then we go through all the following characters. We know this is a useful, we know this is a digit, so we know this is part of the number. But from then on, we say, give me the next character. And if it's a digit, then continue swallowing up those digits, to make our int that we're going to return. But if it's not a digit, here's where our problem is. If it's a plus, we just stop, we just break. That next call has swallowed up the plus, and we need it to not do that. So I think what we want is so last time we wrote an iterator that can be given back more characters, like backtrackable is what we called it. You can if you decide you didn't want to next that character, you can put it back. So I think what we're going to do is that. So we're going to do something like, let's call this, I was going to call it A or something, but let's call it other character. Let's call it other. Let's see how that goes. And we're going to want to put back, or give back is what I called it, other. And then I don't know what other stuff is, like, is this pos offset still right? I'm not sure. We'll see. Now, giveback isn't a method because self.chars is a byte chars, which is a thing which can hold on to, which can give you characters and remembers where you got to. And it doesn't have this give back method. I'm hoping that if we have a look at byte chars, so it's in a, so the thing that you're iterating through is a chars. And I think if we can make this be a, what did I call it? Backtrackable iterator of chars, hopefully something like this, then we'll be able to provide a give back method on byte chars, which just calls give back on chars, I think. So let's let's follow this through. It takes 2 arguments. What does it take? The inner iterator and the type. I guess the type is going to be char. It's interesting. Yeah. So I guess we have to explicitly say the type of thing that is held in this this backtrackable iterator is of type is char. And a chars is not just an iterator, it seems, because it appears to have. Oh no. Okay, all right. We'll get to that in a second. All right. So yeah, we're making a backtrackable iterator, which takes an iterator over something, and we have to explicitly say what that something is. So I feel like maybe there's a clever way of writing this without having to actually specify char here, because it couldn't be anything else, because chars is an iterator over char. But we're going to ignore that for now. All right, so this backtrackable iterator works like an iterator. So all the places where we use it like an iterator, like here, it's fine. At the moment, we've got a problem when we create a new byte chars from a str, because instead of making a backtrackable iterator, we're just making a chars. So we need to just call the constructor of backtrackable iterator like this, and hopefully that will work. Okay, seems reasonably happy. Now, okay, so our next problem is that when we say give back on this, it's complaining that the give back method doesn't exist, but that's because I haven't written it yet. So what I've done is made it possible for me to implement it by making inner be a backtrackable iterator. But now we need to actually make it. Now, what does give back look like? We should copy what it looks like in backtrackable iterator, shouldn't we? It looks like this. And it's just going to call self dot inner dot give back. So we could have somehow, and now we know that the item here, in this case, we know that the item is a char, so we can just go ahead and make it one. We could have somehow exposed inner so that we didn't have to write our own give back method. But I think I prefer making it look simple from the outside, and all it does is delegate to the other one. All right, so how are we doing compile error wise? It looks okay. And all kinds of stuff is failing now, which is interesting. I wasn't expecting quite so much failure. Let's have a look. Let's try and find the simplest test that's failing. Now, okay, so our addition expression test is failing, which is very similar to the one we're trying to get passing. So let's try and figure out why. It's failing because the numbers here are wrong about where these things are. So perhaps this fix up that we've been doing, let's go back to our lexer. This fix up about this pos offset maybe isn't needed anymore, or maybe give back needs to adjust the byte count. Yeah, I think give back needs to adjust the byte count inside chars. So we need some tests for this. So let's look at our tests for byte chars right now. So we've got tests that say counting characters provides the correct answer. Counting multi-byte characters gives the correct answer. So let's do some give backing. Giving back a character adjusts. So I have been thinking while I was just checking before I started this video that I don't like the name of this struct or its method bytes. So we might rename that towards the end of this video. Giving back a character adjusts the count, something like that. Let's just say a 1 byte character for now. No, let's do both in here. So we make a byte chars. We call next and it should say 1. So what should happen when we give back? It should go back to 0, I guess. So let's give it back. It's A that we've just taken out. And it should now say it should now say 0 again. Let's just try that test. Oh, there should be a char. And let's just run this test, because I'm getting really confused with all those tests. So make ourselves some space. Alright, so it fails at the moment because it's returning 1 and it should be returning 0. I guess we also need to test. Well, let's make this look like this. So let's try and add some comments. So given some chars with varying numbers of bytes, when we take a 1 byte character out and put it back, then the count stays at, well, no, let's add an extra one on the front and let's just next it so that we get the different from, because I feel like the 0 case might be special in some way. So let's just do some kind of pull out a character just to make us not start at 0. So when we take it out and put it back, then the count stays, then the count is back to what it was before we nexted, because nexted is now a verb. All right, so let's I changed my mind, because once I've written my given when then, that's the whole test. So let's have another one, giving back a multi-byte character, and let's put both these tests at the end because they shouldn't be splitting up the tests that we had, single byte and multi-byte before. So now we're going to pull out the X and the A, pull out some characters just to make us not start at 0. So now the count should be 2. Then we pull out that character. I think the count should go to 6. And then it should go back to 2. And what we should put back, just to be consistent, you can't pull out a character and then put back something else. We haven't said what should happen if you do that. I mean, in theory, you should be allowed to do that, but it doesn't make sense, so we're not going to do it. Let me take a multi-byte out and put it back. And the count is back to what it was. All right, so now I guess we can test for adjusts the counts. Both these should fail. And And now let's try and write some code that we think will make it work. Self.bytes. So we've got a problem here, which is what to do when it goes negative. Yeah, so the simple implementation is that bytes, that when we push something, when we give something back, we just go backwards in terms of how many bytes we think we've used so far by the length in UTF-8 bytes of this character, because all of this is UTF-8. So our tests pass, but now what happens when we go back further than, like it's a bug, we shouldn't do it, but what happens when we go back before the beginning of the string? So giving back to before beginning of string is, let's just say handled. I'm not sure whether it should be an error or not, but we shouldn't. Something sensible should happen. So this should just be ABC, given some chars, when we give back more, give back, what is this? Give back characters we were never given, brackets, which is not a realistic use case. Oh, come on. I'm obviously not using the nightly formatter. So let's give back an A character, or a Z character, and something large as well. Then let's just say the count is 0 and see whether we can make that one. And then the count remains 0. Now, maybe this should be an error, because really, this, as I'm saying, this shouldn't really happen. As I don't have a use for this thing. So let's run all the tests, see if we get a load of failures. Oh no! All right, so this one is failing. So let's start with this one. Oh, I didn't paste what I thought I'd pasted. Okay, right, so what happens? It panics at line 26, attempt to subtract with overflow. Alright, so, I mean, I guess we're okay with that. We want it, I prefer it to panic in a way that, that gives us more information, and I would like to document that. No, I guess, so interestingly, the give back on the backtrackable iterator is actually totally fine with this. We might decide that it's still not right to allow it because, what are you actually trying to do? You're supposed to be backtracking, but you're actually pushing extra stuff in. So maybe we'd have to rename it to some kind of pushable iterator or something. But actually it's only the give back on byte chars that is really a problem for us. So, add back characters that we have already. Add back a character that we have already provided, that we've previously provided. Panics if given back more characters than we have provided, I guess. Something like that. And then we want to say if so let to give back equal the thing we're going to give back. If to give back is greater than self.bytes, then we're going to panic. Else we're going to do our thing. Yeah, I guess this is like internal compiler error or lexing error. Internal lexing error. giving back more bytes than we have provided. Come on, formatter, make my strings better. Something like that. Now when we run this test, it should panic, saying, internal lexing error, giving back more bytes than we have provided. Alright, that'll do. So let's expect our test to panic. I think you can do something like panic. I can't remember how you do this. Should panic. And I think you can say should panic equals something as well. Should panic equals something like that. Let's see whether that works. It does, okay. Now what if I just expect a different string? Yeah, okay, so it is checking our string is what we expect it to be. Can I do something that makes it formatted nicer? Yes, alright, so we think we've fixed the problem with the characters getting out of sync when we give back, and we've even handled the case where you use this function wrong. So what happens when we run all the tests? We still get lots of failures. Let's start with lex addition expression. Or x addition expression. Alright, so lex addition expression fails because it's attempting to subtract with overflow. That's interesting, isn't it? I wasn't expecting that. Alright, let's go look at this lex addition expression. So we're just lexing 3 space plus space 550. And when we hit that, well, where is it? I guess we should do some logging or something. There's a method called int that we want to look inside, because here's where we're calling give back, and somehow we're subtracting. I'm really shocked. All right, so let's print out what's happening, shall we? So every time we get a character here, let's print out what that is and see at least what character we got to before this all went wrong. So it's immediately after the space. So I would have thought next we'd be giving, next would have been called, and it would have added 1 like this. And so we should just like print out, I guess we should print out self.bytes here. And then when we try and add it back, which will be in this give back method, let's just print out, I think this is too late, but this is where we print out self.bytes. And we should have checked here. We should never get here because, oh, I guess this should be reusing this variable here. That's what I meant to do. So let's print out to give back as well. Yeah, I'm supposed to be checking. If you've got the right number of bytes, then you're okay. Otherwise, we should be okay. Yeah, if it's small enough, we do this. If not, we panic here. So I'm a little surprised. So lex addition expression. So this is the test we're thinking about. First of all, it finds a 1. Oh, no. Number of bytes is 1, then 2, then it sees a space, then it gives back 1 byte, which takes it back to 1 byte again. And then at line 99 of lexer, okay. So this pos offset thing may no longer be a valid thing to do at all. So let's stop removing it just for now. Let's see whether that helps. So only with spaces failed now. That's probably some other problem. Okay. So I think this pos offset, which also felt like a nasty hack, is now no longer needed. And there are other places we do pos offset in, and actually other places we're going to need to give back as well. So we're going to have to deal with that. So now we have only one test failing, and it's because the position of the tokens is wrong. Of course it is. So I think it's just the test that's wrong. So let's have a look. So obviously this is in position 0, and this is in position 2, and then this is in position 3. So I somehow, when I was adjusting the positions, I forgot that I'd actually removed some spaces, so the positions are actually different. Okay, so now we've got passing tests, so let's get rid of all our debug statements. That one too. And let's try our tests. Okay, so lots is going well, and some stuff is going wrong. So lex multiple tokens is failing because there's an unexpected character. So we may have actually broken our actual lexing. So lexing something invalid is an error. Alright, let's start with lex multiple tokens. So back to the lexer. So, alright, so what is our problem here? There's an unexpected space character. So somehow we're not ignoring the space anymore. So we're correctly pushing the space back into the iterator because we got to the end of the number. I think that's right. Like we could say, oh, only push things back if they're not a space, but then we'd have to do the adjustment of the position that we just got rid of, and we like getting rid of it. So something's happened where we've put the space back, and then we've crashed saying, oh, I wasn't expecting a space. So that's panicking at line 369. No. It's failing because there's an unexpected character. So let's have a look for unexpected character. Here. So we've got to here. And we should have done this. But somehow this didn't work. Is it because it's not actually a space, or does this not work the way I was expecting it to work? Let's think a bit about how the lex next function works. So basically, we look for the first character, call it ch. In this case, I would have thought our first character would be space, and we should therefore hit the space thing and not hit this code. Now, is there anywhere else we get an unexpected character? Seems not. Yeah, so it's definitely getting to here. And so when I was just thinking, like, does this get in some kind of infinite loop? But when we call lex next again, that calls next again. And we're not doing any kind of give back here. So I really don't see why we're not getting to here. So let's print out ch. And just double check that it's happening in the place I think it's happening for a start. So lex multiple tokens. Like so. It's printing out some stuff. Ah, okay. Okay. So the problem is actually the new line at the end. The space was fine. Okay. These characters are not what I was expecting to see. What is lex multiple characters actually? Multiple tokens. 1765. So why is it printing out a 1? Should be 1765 and then it should stop, right? It feels like it's gone back to the beginning or something. Oh, no. Okay, it's this. It's this. Fine, right. Getting myself completely confused because I foolishly tested 2 things in one test. So it's the second instance of the test that deals with a new line that's causing us all of our problems. And can we jump to the right bit of code? So we are not handling other types of whitespace. So I guess to make this test pass, we can just say new lines should also get skipped. And our test passes. All right. How does that? Oh, now all of our tests pass. Okay, so it seems like we've added, we've figured out how to add this feature to the lexer, but we've only done it in one place. So let's look at things that are not integers, that also are going to need to work without whitespace. So this is our big example, where there's at least this situation, and I don't know whether the semicolon will now be working without the space or not. Can we do a small example? Can we copy a small example? No. Why don't we do the big example? What if we just got rid of spaces here? Well, no. I think I actually want to do another one. Just in case we introduce some problem that means that with spaces doesn't work. Let's do one with no spaces, except where they have to be. How about this? That should have exactly the same lexing as the version with all those spaces in. And at the moment it won't work. Lex assignment statement's also gone wrong. What did I change in lex assignment statement? That's weird. Oh, yeah. There we go. So now it should only fail in our new test. Yeah, our new test fails because the only place where we've done that give back is inside the int thing. But actually, everywhere where we do any adjusting, so there's like a trick we can use, which is anytime we adjust the token position, which I guess is only going to be in symbol or keyword. So anytime we use pos offset, so let's search for pos offset. Okay, they're only used in here. So let's stop using pos offset. Call this other like we did before and say self.chars.giveback other. And then get rid of the pos offset. With any luck, it all just works. Close. Oh, I guess the character positions are wrong, so let's fix those before we analyze that error message in detail, because it's going to be annoying. So, X is in the same place. The equal sign is 1 earlier. The 3 is 2 earlier. The semicolon is 3 earlier. The X is 4 earlier. The plus is 5 earlier. And the 4 is 6 earlier, I think. Let's try that. And we're going to have to analyze the error message if it doesn't work. So let at 0.3, X at 4.1, equals at 5.1, int 3 at 6.1, semicolon at 7.1, X at 8.1, plus at, should be at 9.1, and then 4 at 10.1. So, the plus has come out with completely the wrong number. Oh, it's because I typed the wrong number? Okay, I was getting really worried then that my code did something weird, but it wasn't the code, it was my test that was wrong. Okay. All right, so I think we have a coherent change here. Oh, and we didn't do a commit from before. That was terrible, wasn't it? So let's do a commit now. Double check that it looks sensible. Backtrackable iterator with all of its tests. And then using the backtrackable iterator in the lexer. And we've also made a change where we're using the backtrackable iterator in the parser, which unfortunately is all going to go into one commit, which is terrible. I should have done a commit in the last video. Use a backtrackable iterator in lexer and parser. Now there's one other thing that I would like to do, which I think I'll squeeze into this video too, which is I want to rename that byte chars thing. I think this should be called chars with byte. Well, for chars with pos. Okay. And that means we need to rename this file, which is really annoying. Instead of calling it byte chars, it should be called chars with. Did I call it chars with pos? Yep. Okay, and now everything's broken. This should be called chars with pos. Everything's broken in here. But eventually it's gonna be happy with me. We have to search for. I could probably have done this better. Byte chars. So the rename. Okay. No, it should be called byte underscore chars. I'm sure you can rename files using the refactoring tool, and none of this pain would be happening right now. Chars with pos. I guess we should rename this function as well. Iterating over chars with pos. And if and when it's happy with me, I also want to okay, it's happy with me, good. I also want to rename the function. So this variable should be called bytes pos. Pos in bytes, pos, bytes. And I guess that means byte should also be called pos bytes. I want the word bytes in there because I want it to be clear that that it is in bytes. Like the units really matter here. It's not a position in characters, it's a position in bytes. Okay, how are we doing? Okay. Rename to pos chars with pos. Let's just say rename, I guess, iterator. So that the reason I wanted to do that was byte chars did not express what this does. What this does is it's a chars, it wraps a chars, but it also remembers your byte position within that, how many bytes you've already seen so far. So chars with pos, I think, and then pos in bytes gives you like some idea of what this thing is supposed to do. All right. So just to recap, because that was a distraction, what we've done today is we have made our lexer put back characters that you haven't used yet back into the iterator. Same way we did with the parser in the last video. If I come across a character that it turns out I don't want to consume, I put it back. And like we talked about in the last video, one way of doing that would be to peek it and then only consume it if you don't, if you really want it. But I prefer consuming it and then putting it back if we change our mind, because it just feels more natural than doing a peek and a grab it later in the normal case, which is that we do want to grab everything. Is that normal? I don't know. Anyway, so for better or for worse, that's the way we're doing it. So anytime we're consuming a load of characters, we can give them back if it turns out we didn't need them anymore. We didn't need them in the first place. And that means that we're now able to pass these tests where we can lex things without spaces in between them, including this example of something a bit more complicated. Let's double check that we can actually do this in practice. X plus 1, let's say. Pass that into cargo run. And we're not yet able to evaluate that expression, but we can do 4 plus 1 without spaces, and it gives us back 5. So it's working. Next time, I guess, we're going to look at whether we can make this actually work by doing the first bit of actually having variables that exist in our interpreter. And I don't know, eventually that's going to cause us to make all kinds of decisions, so many of which I don't feel ready to make yet. But let's do the dumbest thing we can to make our test pass. Have an environment, which is like the place where variables are stored in an interpreter. And then we'll gradually add scope and stuff like that. And eventually we'll have to worry about how the types really work, and it's all going to get extremely interesting. But we're going to take it a step at a time, because that's the only way my brain works, and hopefully that's a useful way for you. Hope you enjoyed, and see you next time.